going to do 3 questions on pH and indicators. The first one is 2018. It's question 11b. Okay, the first part of the question says, what is the Arrhenius definition of a base? So the Arrhenius base is one that dissociates in aqueous solution to produce H plus ions. Oh, sorry, to produce OH minus ions if it's a base, H plus ions if it's an acid. Okay, so the first part. The second part says, why is ammonia considered a Bronsted-Lowry base? So ammonia, if you put ammonia into a solution, what will happen to it? It will accept a proton and become NH4 plus, and you'll form OH minuses. So the NH3 has gone to NH4 plus, so it's accepted a proton, which means it has to be a Bronsted-Lowry base. That's why it's considered a base. Okay, calculate the pH of a 0.5 molar HCl solution. Calculate the pH of a 0.5 molar HCl solution. Right then, so the pH is equal to minus the log of the H plus ions. So in this particular case, what happens to HCl? Well, it splits into H pluses and Cl minus. 1 mole of HCl will give you 1 mole of H plus. 0.5 moles of HCl will give you 0.5 moles of those H pluses. So therefore, the pH is equal to minus the log of 0.5. And if you hit that into your calculator, where is it? Minus the log of 0.5 is 0.3. So you have a pH of 0.3. Okay, the next one, it says, second part of that question, a 0.5 molar ethanoic acid solution. Ethanoic acid is CH3COOH. Of course, it's a weak acid, I know that, so it doesn't fully dissociate into its ions. It just partially dissociates, which means 1 mole of acid will give me 1 mole of H pluses. So what I need to do now is find the pH of this weak acid. I know that it's minus the log of the square root of the Ka by molarity. So I'm going to put the values in that I'm given in the question. I'm told that the Ka is 1.8 by 10 to the minus 5. I'm going to multiply it by a 0.5 molar solution, because 1 mole gives me 1 mole, so 0.5 moles gives me 0.5 moles. And when I hit that into my calculator, what will I get? So I've got 1.8. That will become minus the log of the square root of 9 by 10 to the minus 6. And when I square root that, I'll get minus the log of 3 by 10 to the minus 3. So when I work that out, I get a pH of 2.523. Okay. The next part is you're given a pH curve, and it says you're going to add 100 centimetres cubed of sodium hydroxide to an acid solution. Which of the 2 acid solutions was neutralised? Now, if you look carefully at that graph, you can see that the pH of the starting position, so the starting pH, when you start adding that base, the pH was at around the 2.5 mark. So therefore, which one of these 2 acids could it be? Of course, the pH of the ethanoic acid is 2.5, so that means the starting point, if it's indicating 2.5, I'd have to suggest it's an ethanoic acid solution, not HCl solution. And then it asks me, I'm after losing that question now, sorry, 11b, then it asks me to state 2 pieces of evidence, okay? So 2 pieces of evidence from the graph in support of my answer? Well, the first piece of evidence is that the starting pH is 2.5, and that's the first part. So the starting pH is 2.5, and the pH of the ethanoic acid solution that I have is 2.523, so they must be the same solution. Okay, so that's my first piece of evidence. My second piece of evidence says I'm going to look at the curve. So my second piece of evidence is that I can see it's sodium hydroxide being titrated with ethanoic acid. So it's a strong base versus a weak acid. The end point, which is where the vertical part of the graph is the vertical part is just above the 7. So the vertical part of the graph, I can look at it and I can see that the vertical part is between 7 and 11 on the graph, which means that this coincides with the titration for a weak acid. So which implies a weak acid titration, strong base, and that weak acid is therefore ethanoic acid. I know that's a weak acid, so I'd use that one. Okay.